All right. As Todd said, my name is Cody Gruen, and together with David, we're going to go over some of the nutrient management studies that we conducted at Southern Min over the last year and number of years. And you can see the talks there. We will start with a presentation that is titled, Will Increasing Plant Population Offset the Quality Drag in High Nitrogen? So Southern Min recommends a soil nitrogen recommendation of 110 to 150 pounds of nitrogen per acre. The situation can arise and has arisen where a sugar beet crop is attempted to be grown on a nitrogen rate that is higher than that recommendation. And we've had producers that are concerned with quality drag reach out to us and ask if an option that they have available is to increase their plant population. In theory, if you think of the nitrogen per acre in terms of nitrogen per plant, if you increase your plants, you have less nitrogen per plant. You can't remove the nitrogen, but you can put in more plants per acre. So we ran 5 trials, 2 trials in 2019, 2 in 2020, and 1 in 21 to answer this question. And for reference, we at Southern Min recommend a final plant population of 200 beets per 100 foot of row. So okay, the slide here, you can see a example layout in the middle of the slide of what one of these trials would have looked like on any given year. There's 6 replications of 6-row plots with 4 nitrogen rates ranging on the side there from 120 to 240. You can see that only one of the 4 nitrogen rates lies within our recommendation, and 3 are outside, progressively outside the recommendation. We do have 2 populations, 185 and 300 beets per 100 foot of row. 185 is the population that is right in the middle, more or less, of the production guide's recommendation of 175 to 200. And 300 beets per 100 foot of row corresponds with the trials that were conducted to provide that recommendation in the production guide. Also, we chose the 300 beets per 100 foot of row because if our thought process was that if we cannot see an effect at that high end at 300, we probably wouldn't see anything at a lower population than that. So these trials were seeded at 127,000 seeds per acre, or about 530 beets per 100 foot of row, which is considerably over what our treatment spacings are going to have to be. But after 28 days, we did an emergence count. And as everyone is aware, we do not get 100% emergence with sugar beets. So that overseeding allowed us to have the number of beets available to thin and then get to the appropriate spacings between beets that would correspond to the treatment populations. Much like the rest of the presentations that David will be giving here, the pesticides for production were in line with the best management practices, and we tried to harvest right around the beginning of main harvest for these trials. The trials are typically 6-row trials, this one was, and we defoliate with the 6-row defoliator, and we take our research harvester through harvesting the center 2 rows of the 6-row plots. And on the harvester, we collect the weights for yield and a quality sample for analysis through the tear lab. So if we look at data, this is going to be looking at population on the whole, just averaging across all of the nitrogen rates to see what the general trend is and how it's behaving at these 5 different locations that we combined. So you can see that any metric that is bold-faced is statistically significant. So you can see 3 metrics, sugar, purity, and EST, the quality metrics, that return non-significant for population, which is a little bit of foreshadowing for what the answer will be to the original question of this slide or this presentation. And you can see that makes sense. Sugar was unimpacted at 16.8 for the high and low. And while they are statistically significant, a yield gain of less than a ton is agronomically insignificant. So we did see a response. It's a feather in the cap for a trial that was able to tell that difference, but it really has no impact and would not cover the somewhat close to 60% added seed cost that would take to get to the higher population. If we look at the same type of table, but for nitrogen rates, so we have the 4 nitrogen rates and the average for each of these is including the high and low population. We can see that for all metrics, we do have significance from the high to low rates. And in line with thinking and other literature, we see that the quality metrics, sugar purity and EST, each uniformly decrease as we increase nitrogen. And the inverse is true for yield. As we increase nitrogen rate, you can see that we do get a bump in yield as we go higher and higher. And interestingly, the ESA, I'll call your attention to the far right column. They are statistically different, but all within a few hundred pounds. So while we are seeing that drag on sugar as we increased nitrogen rate, it compensated with yield. So you can see that at the end, all four of those numbers reported for ESA are very close to one another. So did we answer the question though? Will increasing population offset that quality drag? And one way to look at it would be going over EST. So on this graph, we have EST on the left-hand side on the y-axis in pounds, and then we have all 8 treatments on the x-axis. So you can see they're in groups of nitrogen rate, so 120, 160, and so on. And then the green bars correspond to the low population and gray bars correspond to the high. So the first thing that you can do to look at this is compare within nitrogen rates. You can see that for almost every single comparison, we actually decreased our quality by increasing population, except for the 240 pound rate. Now that said, these differences are between a pound and 4 pounds of sugar per ton. They are not significant. To have that added seed cost on top of, to go from 185 to 300, we do see that 1 pound or 2 pound gain at the highest rate, but it won't cover up the cover or get a return on investment for the seed that you had to plant to be able to get to that population. The other way to think about it would be, does the gray bar at any of the higher rates of nitrogen, so for 240 pounds at 300 plants per 100 foot a row, does that gray bar get you close to or above any of the green bars at the lower rates? And it does not. The other metric to look at would be extractable sugar per acre. On this graph, we have ESA on the y-axis and the same spread on the x-axis. And you can see, similar to the graph or the table that I showed on nitrogen rate in general, the data were very close together. So the first thing to point out on this graph is, while there may be numeric peaks, all of the data lie within 500 pounds of ESA of one another. So the differences here are fairly insignificant, although they do show up to 319 pounds gained by increasing your plant population. You did not gain on the whole when you factor in the lower nitrogen rates, and if you were able to offset that quality drag. We can see that in terms of ESA, everything from the recommended rate to the high of 240 pounds all lie within 500 pounds of ESA of one another. So in summary, we do have numeric trends that show that there may be something going on, but nothing that would be statistically significant to show that we would want to increase plant population to the populations that we tested to offset the quality drag. The economics don't pencil out when we factor in the added cost of seed, and that there was general observations in this data that lined up with our typical thinking and literature, that as soil nitrogen content increased, our tons increased, but we did see that extractable sugar per ton decrease. So I will turn it over to David.
Morning, everyone. I'd just like to reiterate what Todd said, that I'm going to cover several trials today, but this will be in the research report that'll be posted later this month, so you can get all the information on there. First trial, looking at nitrogen management for corn grown after unharvested sugar beets. So do we need to manage our field corn differently following sugar beets if they are not harvested? This trial was conducted over 3 years. I'm only going to cover the materials and methods for the 2021 trial, as the years were very similar. Following the 2020 beet crop, we had a cooperator set aside a small portion of his field untouched. We went in with our equipment and defoliated the beets, and then we harvested selected plots and left other plots unharvested. And then we left the field alone after that. In the spring, we came in and applied urea and incorporated that with a field cultivator. We planted on May 6th, hand harvested September 30th. And again, I'd just like to point out protocols are very similar. However, the environments were very different. In 2018, we had a historically wet year. In 2020, it was ideal for growing field corn. And then in 2021, it was a very dry year, especially up in the area where we had this trial. So, all right, there we go. Here's a drone image, 2020. You can see in the drone image that we have color differences between the treatments going across the different nitrogen rates. You can also see differences in the height of the corn as we go across the trial in the lower image on the right. Here's a treatment list for this trial. We had 9 treatments. You can see treatments 1 through 6 were not harvested, and treatments 7 through 9 were harvested. 2 of the treatments did not receive starter, treatment 1 and treatment 8. However, the rest of the treatments received a starter of 7 gallons of 1034O plus a pound of zinc. And these are the nitrogen rates that were used for these treatments. We use the University of Minnesota recommendation, 155 pounds of nitrogen for our standard. We also included 40 pounds less than that recommendation for treatment 3, 40 pounds above and 80 pounds above for the not harvested beet plots. And then for the harvested plot, we had the recommended rate at 155. Here we can see the grain yield for all 3 years, 2018, 2020, and 2021. I'll just point out a few things on this slide. You can see that we had a response to our starter in 2 out of the 3 years for the not harvested beet plots. And if you look at the lower portion of the table here, we had a response to the harvested beets as well. If we look at the not harvested plot with the recommended rate of nitrogen, we can see we had 173 pounds in 2018, 234 bushels, excuse me, in 2020, and then 112 bushels in 2021. If we look at the response to added nitrogen, we can see that we increased our yield to 242 bushels in 2018 with an additional 80 pounds of nitrogen. We increased it to 255 with 40 pounds of additional nitrogen in 2020. Same for 2021, where we saw a nice response to the additional 40 pounds of nitrogen. So just a quick summary for that trial. Using starter may be beneficial and is a good practice for field corn following sugar beets. Adding additional nitrogen of 40 or more pounds will improve yields, and basically just treat it like a corn on corn rotation. So moving on to our nitrogen rate trials, we had 2 trials, one located just north of Renville and the other located south of Hector. This is a drone image of the Hector or the Renville location. It's at the middle of the site here. We ran it as a randomized complete block design with 6 reps. You can see in the image that we did have some stand loss due to the very dry conditions that we planted into, but also, as we've seen in the last couple of years, we've had stand loss due to the higher rates of urea that are applied. Materials and methods are very similar to what Cody explained earlier, so I won't spend a lot of time on that. Our treatments are applied to spring urea and incorporate a field cultivator. This site was planted on April 22nd following a soybean crop and harvested on October 11th, again, harvesting the center 2 rows. We had a residual nitrogen test, 0 to 4 feet, 55 pounds. So that's our baseline check for the site. And then we went up in increments of 30 for our nitrogen rates for each of the additional treatments. Some of the yield parameters for this trial, we can see the root yield had a nice response going from 38 tons up to 44 tons with an additional 60 pounds of nitrogen over the check. And then after that, it is fairly flat response. If you're looking at the extractable sucrose per acre, a very similar response going up to that 115 pounds of total nitrogen, and then a fairly flat response after that with the additional nitrogen rates. Our second location, south of Hector, this is a nice drone image of the site. It's a rather large site. This area here is actually Secosper leaf spot trials that I will talk about this afternoon. Over here is a potassium by nitrogen rate that I will cover in a couple minutes. And then right here is the nitrogen rate trial that I'll be talking about right now. Very similar material and methods again. This site was following field corn and harvested on September 29th. Here's a nice visual looking at the nitrogen response for this site. We had 155 pounds of total N on the left compared to the check of 45 pounds on the right. And you can see that we did have a substantial amount of field corn residue on this site. Here is the treatment list for this site. We had a residual nitrogen test of 45 pounds, 0 to 4 feet. And then similar to the Renville site, we went up in increments of 30. The total N is just 10 pounds less for each treatment than the other site. Our responses were very similar to the other location, starting out with a lower yield at 33 ton for the check, going up with a nice response though, and then flattening out again with the higher rates. You can see the EST starts out at 250, pretty flat for the first couple of treatments, and then we start seeing a negative response for that parameter. And then again, the ESA, very similar response to the tons per acre, going up and then flattening out. So looking at both locations, we can see in these graphs the Renville site in red, the Hector site in black. We have our root yield on tons per acre on the y-axis and our total nitrogen. So this is residual plus applied on the x-axis. This is just a graph showing the same numbers as the tables that I showed. The line of best fit for this analysis was a quadratic plateau. So you can see we have increasing response to our nitrogen up to a certain point, and then the response flatlines. This is the same for root yield and for extractable sucrose on pounds per acre. However, if we look at the EST or extractable sucrose in pounds per ton, you can see the Renville again in red, Hector in black. We have a negative linear response as our line of best fit. If you're looking at the data points, you can see that they're fairly flat for the first couple of rates, maybe up to 150 pounds. And then after that, we start seeing that negative response. So there's lots of different parameters to look at. So just looking at a few of these things, you know, what is our total, or what is our optimal total N that we should be applying? If we're looking at tons in the 2021 trials, the Renville site would be 191 pounds and the Hector site would be 145. However, if you're looking at optimal total N for ESA in these trials, the Renville site would be 117 and the Hector site would be 93. These fit in very in line with our historical data, where the optimal total N for ESA for 2010 to 2020 is 131 pounds if we're considering that the cost of nitrogen is $0. So, you know, we get into the part of what factors do we look at for determining success. In this presentation, I've talked about 3 different factors. It can be hard to know which ones you should be looking at. And Steve Rail will actually be talking about that this afternoon. So this is our potassium by nitrogen rate trial. You can see that we had a visual response in this trial site. The purpose of this trial was to look at, do we need to adjust our potassium rates as our nitrogen rate varies? So here's a little closer visual look at the response. We had 75 pounds of total N here on the left and 170 pounds here on the right. So we did have a nitrogen response at this trial. So we're looking at extractable sucrose on pounds per acre for the y-axis. our nitrogen rates, 75, 170, and 240 on the x-axis. And then our lines are the different rates of potassium applied as potash, going up in increments of 30 from 0 to 120. So if we look at the first nitrogen rate at 75 pounds, we can see that our potassium rates are pretty well clustered together here, not seeing really a response to potassium rate for 75 pounds of N. When we increase the nitrogen rate to 170 pounds, we can see we have a nitrogen response, but the potassium rates stay very closely grouped, so we do not see a response to potassium. If we increase the nitrogen rate again to 240 pounds, we see that we do not have a nitrogen response or a potassium response as we increase the nitrogen to 240. So in a nutshell, we did not see a response to changing the potassium rate as the nitrogen rate varies. However, this is the first year this trial was conducted, and we'll conduct it again in 2022. Just real quickly, we've conducted the sugar enhancement trial for several years. Just want to throw it out here for you guys to look at quickly, but it will be in the research report, as I said earlier. The purpose of the sugar enhancement trial is to increase the quality of our beets. So we look at a variety of different products to do that. I'm just going to point out our check at 110 pounds of total N, that's residual plus applied, was at 17.2% sugar. And if we go down the column, we see that nothing that we applied increased our sugar percentage. So we did not see a response to any of the products for the quality. I will point out just an interesting thing that was observed. We saw a decrease in our sugar percentage and an increase in our tons with an additional 40 pounds of N. However, that does not change our total ESA. So again, how do you determine success? We didn't see anything in our data that would suggest that we should change our nitrogen recommendations moving forward into 2022. Looking at a nitrogen management zone of 110 to 150 pounds. Again, it's very important that we know what is in our field so we can apply the appropriate amount of fertilizer. So we suggest having a residual nitrogen test 0 to 4 feet if possible. This is very important moving into the 2022 season, as the drought that we experienced in 2021 made a lot of nitrogen unavailable for plant uptake. And then when it was available in the fall, the plants were not necessarily utilizing that nitrogen. And we've seen historically high levels compared to the last 5 years in the sampling data so far. Other factors to take into consideration, not really going to cover these. You guys can look at them just for the purpose of getting back on track with our time. Just things for you guys to take into consideration where you want to be within this nitrogen management zone. And just to acknowledge our cooperators. Without them, we can't conduct this research. And to our University of Minnesota personnel that help us as well, Dr. Dan Kaiser and Dr. John Lamb. Thank you very much, and we'll move on.